Well, hello everyone. I am Snigdha Kakkar and this is my channel AccelerateAICareers. I hope you enjoyed my last video for Leetcode 7 top questions asked in last 1 month of FAANG interviews. So today I have brought you another very interesting question, Leetcode 279 perfect squares. It's one of the favorites for Amazon, Meta, Microsoft and Salesforce for their interviews in last 30 days. So let's see what does this question say and why is it a medium level problem here. So you have been given an integer n, then n could be random number, and you return the least number of perfect square numbers that will sum up to n. A perfect square, if I might remind you, is any integer that is the square of another integer, like 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, 16 is the square of 4, and so on. So these all are perfect squares, while 3 and 11 are not perfect squares. So let's look at a few examples. So like you have example 1 where n given to you is 12 and your output, how would you calculate that? So what your output is 3, that is you require bare minimum of 3 perfect squares, which is 4 plus 4 plus 4, such that those perfect squares sum up to 12. Now you would say it could also have been 9 plus 1 plus 1 plus 1, but in that case, the perfect squares number is equal to 4. So that's why you need the minimum number of perfect squares which sum up to n. Now in example 2, you have n equal to 13 and n equal to 13 can be achieved by 9 plus 4. That is, you require only 2 perfect squares that will sum up to n, that is 13 here. Let me remind you, I have solved a similar question called coin change, which has exactly same logic. So if you are able to solve this, you'll be able to solve that and vice versa. Now you would say that I can solve it by using greedy method approach. And suppose my n given to me is 12. In such a scenario, what is the largest perfect square less than 12? The largest perfect square less than 12 is 9. So I will take 9 first. And then I will see if I can add any largest perfect square less than 9 or equal to 9 to it to get 12. So if I add 4, 9 plus 4 is 13, which is greater than 12. So that cannot be possible. Then I have only one option remaining, which is 1. So 9 plus 1 is 10. And then I have to add 1 again. 10 plus 1 is 11. And 11 plus 1 is 12. So I'll have 4 perfect squares that will sum up to 12 here. But is there a better solution? The better solution would be don't start with the highest one, highest perfect square, which is less than 12. Instead, find the requisite perfect square. So instead of starting with 9, you start with 4 or you start with 1. So if you start with 4, in such a scenario, 12 minus 4, that is 8. So you need another perfect square that sums up to 8, which is 4 plus 4, right? So you need 3 perfect square, which is 4 plus 4, 4 plus 4, that sums to 12. So this example clarifies that it's not a greedy approach question, and if you try solving it with greedy approach, your answer will always be incorrect, or sometimes it's hit and trial and sometimes it might come correct, but that will not always be the case. So your examiner is actually looking for a dynamic programming based solution here, a bottoms up solution. So how do you go about that? So any DP question can be represented using a decision tree. So if say suppose initially you have n equal to 12 and you want to get the sum of perfect squares equal to 12 here, you can either take a choice of 1 or you can take a choice of 4 or you can take a choice of 9 because 16 is greater than 12, so that's not possible. So you have only 3 choices to make 1, 4 or 9. You can take either one as the starting point and then you go ahead. After that, say suppose I take 1. Then after 1, you can take again 3 choices, either 1 or 4 or 9. And that's how you keep on exploring. And every time, every level you take, say suppose you take 1, 4 or 9, any one choice, any one starting base initially. Suppose I try to go with 1. In such a scenario, at the next level, I don't need some perfect square to sum to 12. I need perfect square to sum to 11 because I already have 1 as the starting point. And then at next level, say suppose I choose to go with 4. In such a scenario, 4 plus 1, 5. So I need 12 minus 5, that is 7, as the sum of next perfect square and so on. So you keep on updating your n and you keep on selecting one or more choices. And why it is bottoms up? Because you start with one initial point to reach that n. So I hope you understand this question. Why you'll understand the approach better once we start coding it. As far as time complexity of this solution is concerned, so you know that your choice of digits can be anything, but it is limited by n, right? You cannot go beyond n. And it is also limited by root n. Root 12 is 3 point something. And if you see, our squares have reached only till 3 square. You cannot have 4 square here because root n is less than 4, right? So your time complexity here would be O of n multiplied by root n. So this is a solution of this time complexity. And you're not using any additional space except for your DP array. So your space complexity would again be O of n. So let's start coding this question. That way it would be much clearer on what we are trying to do and how we are trying to solve it. Yes, so what could be the basic solution for my problem? Suppose n is 12. 12 can be reached by 1 plus 1 plus 1 12 times, right? So that is possible for any integer, right? So this would be my base case. I will initialize my DP array with that is 12 multiplied by n plus 1 times. So basically I'm assuming that it takes n steps or n times of perfect square, that is 1, to be added for n times. So basically I'm assuming that the maximum case to get n, that is 12 here, is 1 plus 1 plus 1, that is 12 times 12, but 12 times 1. Okay, so that's how I initialize my entire DP array with n value, that it takes n perfect squares to sum up to reach n. That's what I've done. And I'll also initialize my DP0 value with 0 because it takes 0 perfect squares to sum up to 0, right? That's a true fact, right? You can achieve a sum of 0 by using 0 perfect squares. Now I will have my first for loop, which will be for target 1 to n plus 1, because I have already DP0 computed, which is 0. And in Python, the range is non-inclusive. So the n plus 1 actually is not included. Your range is between 1 to. And then I'll have a nested loop for s in range. That is my squares, which I will compute. For that, I'm taking for s in range 1 to target plus 1. Because I will have to update my target every time I run through the loop, right? Say suppose my initially is 12. My target is also 12 then. I pick up a choice that I will go with first perfect square as 4. So then my new target value would be 12 minus 4, 8. So that's what this nested loop is. It will calculate squares starting from 1 and then 2 and then 3 and then take those squares and check if my target minus square is greater than 0 or less than 0. Like if the solution with that particular square value is possible or not. So I first compute my square here and then I check if target minus square is less than 0. In case it is less than 0, then that square cannot be a part of your solution. That perfect square is outside your range, so you break. If that is not the case and that perfect square is within your range, in such a scenario, you can update your DP value. So your DP value of target will get updated as minimum of your current DP target value, like you have set all your DP values as n initially, right? So it will either get updated to DP target, which it is current, or DP of target minus square. Suppose your first choice was to go with square of 2, that is 4. So 12 minus 4, 8. So your new DP target minus square would be DP of 8. So now you would check if how many perfect squares does it take to make 8, not to make 12. So your DP 12 would be minimum of DP 12 and DP 8. But you also should not forget that you used 1 square just now. You used a 4 just now when you did 12 minus 4. So you have to add a 1 here. So basically your DP12 would be minimum of DP12 and 1 plus DP8. That's your entire solution. After that, you just need to return DPn, which is your answer required. How many perfect squares are needed to reach n? And this is your dynamic programming bottoms-up approach. I hope the solution is clear to you. Let me walk you through the solution once again. You first initialize your DP array with default values of n for the n variables you want to calculate, and then you initialize your DP0 as 0. That's your base case. because it takes 0 perfect squares to have a sum of 0. And then you ran your first for loop, which is for target in range 1 to n plus 1. And then your nested for loop, which is for s in range 1 to target plus 1, where you compute all the squares starting from integer 1, and you check if your target minus square is positive or negative. If it is negative, that means that square excludes your range. It's not within your range, so you break. If it is within your range, you update your DP target by taking minimum of its actual value currently, or 1 plus DP target minus square. So in this case, when n is 12, your DP target minus square could be DP of 12 minus 1 or DP of 12 minus 9. And you return DP. So that's your entire solution. Let's is accepted. Let's submit. And that's my entire solution. Type complexity, again, I would repeat, is O of n into root n. I hope it is clear to you. There are several more optimum solutions possible which have more mathematics in them. But I think your examiner would be looking for this approach because they're interested in seeing if you understand dynamic programming, if you understand why greedy is not applicable here, and if you understand how to apply DP here. So if you have any other doubts, mention them in the comments. I'll be happy to address it. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.